about light and lenses. This is when things get really exciting in light. Now, remember, refraction is bending of light as it goes from one medium to another. Now, we use the phrase transparent as it goes from one transparent medium to another because clearly if it's opaque, then light isn't traveling. Opaque means you can't see through it. Now, when light goes from one transparent medium to another, it changes direction at the boundary. And how it changes depends upon the materials. Now, we call the incident ray, all right, or we call the incoming ray the incident ray, and we label theta I. If this is my normal, remember the normal is always perpendicular to your surface. So here is my surface. All right, the incident angle is always from the normal to the surface, while the refracted ray is always from the normal to the ray of refraction. So key things to remember: normal is perpendicular to the surface. Theta I is your incident ray. Theta R is your refracted ray. Now make sure you can label these. It turns out the speed of light actually changes when it goes from one medium to the next. When light goes from a medium where the speed is faster to where it is slower, it bends toward the normal. For example, if you go from air to glass, it bends toward the normal. So this would be air, and this would be glass. It bends toward the normal. If it goes from a medium, from slower speed to faster speed, it bends away from the normal. So this would be a really good example of going from glass to air. Remember, light is reversible. It doesn't matter whether it's coming in from air and going to glass or going from glass to air. These angles are always going to be the same. Now, if the incident rays are parallel to the normal, there's no refraction. All right, because it's just going to go straight down. And as I said, that path is reversible, which just means it doesn't matter which direction you're going. Now let's discuss the index of refraction. It is a ratio of the speed of light in air or in a vacuum to the speed of light in that medium. And it is always greater than 1. In air is the smallest, has the smallest index of refraction. Well, we're going to call that 1 just because it really is really close. Now, the index of refraction has no units because it's a ratio of 2 speeds. And remember, the speed of light is 3 times 10 to the 8th meters per second. You need to know that constant. And V, of course, depends on the medium or the material. We've already discussed this. Now, what happens to the velocity as the index of refraction gets larger? Think about it. The larger the index of refraction, the slower light travels because N is C over V. All right. So a larger index of refraction means that V is smaller. And therefore, the more the ray is going to bend or refract when it passes. So large N means slower velocity, which means it bends more. You feeling some multiple choice questions in there? Now, it turns out objects appear in different positions due to this refraction. Anyone who's ever gone swimming or diving for pennies in a pool has discovered this. To find the angle of refraction, we use what's called Snell's law, which is N1 times sine, this is theta 1, is equal to N2, where this is my second material, sine theta 2. Now, guys, it doesn't matter how you label these as long as you're consistent. N1, sine theta 1, N2, sine theta 2. You're going to be able to figure it out. Now, one more thing. You must be in degrees. In physics, we always give it to you in degrees. We never give it to you in radians. So, remember, from a faster medium to a slower medium, it's going to bend toward the normal. And you can find the actual number by N1 sine theta 1 equals N2 sine theta 2. Now, lenses are an excellent example of light going from one medium to another. We can form images by refraction instead of reflection. Now, these can be real or virtual depending upon the type of lens. And lenses use Snell's law in telescopes, microscopes, cameras, and even your eye. A really cool study is to go study how your eye forms images.